There's 2 annual conferences and sponsors. We sponsor free local events and do workshops and all this kind of stuff. Be sure to read the Code of Conduct for Techlahoma. It applies at all these events. And reach out to someone in the conduct team. There's a contact on the website if you feel like there's a violation of the Code of Conduct. So we do all this to support the grassroots technology community in Oklahoma. You can learn more at techlahoma.org, and you can help out by checking out the other meetups, looking at the Techlahoma Help Wanted board. The ways you can support Techlahoma, you can donate, obviously. You can also set it on Amazon Smile or a Twitch subscription. You can ask your company to sponsor, and there's a merchandise store. We get some proceeds from all of that stuff. There's the license plate, which I think if you signed the petition for, now you have to go and actually go do the license plate thing. We have to get 100 people to do the license plate before they'll start printing them. So then 36 Degrees North donates the space for us to meet. So they also offer free workshops and co-working, desks and offices for a monthly fee. You can find out more info at the front desk. I think it's Levi taking care of us. He's also gone, so everyone is abandoning me tonight. You all stay here. No one else gets to lead. So if you check the 36 Degrees North calendar, they have a bunch of the other meetups that happen here. And then some of the ones that we'll call out. So February 20th is free co-working day. That's Wednesday. So if you want to check out 36 Degrees North as a co-working space and see what it's like to co-work here, that day is free co-working. February 21st, binary governance. Who put this on here? Oh, yeah, that's the TU thing. You want us to talk about it? Oh, or should I, because I'm at the microphone?
It's all up there.
All right, so it's all up here. There's basically, it's a guest lecture on the accountability of algorithms. So it's about algorithms. It's at the College of Law. So I think it dips into how algorithms are used in legal practice, criminal justice, all that kind of stuff. So that's February 21st, and I believe it's at TU Law, right?
Yep.
Okay, so yes, it's there. And then February 23rd, that's this Saturday. Yeah, Digital Privacy and Security Workshop. So I'll be doing this at Tulsa Library if you want to come, either to attend or to just heckle me or to help me hopefully install one password on a lot of other people's devices who are going to be attending.
Let's not show up like everybody else.
Yeah, or you could abandon me like everyone is doing tonight. February 26th is Tulsa Lambda Lunch. That's here. Is Darren here? Talk about the talk. Okay.
What time is the digital lab?
It is at 9 a.m., I believe. Or at least that's when I'll go there. So we can hang out if it doesn't start till 10. Then March 12th, Tulsa UX. I don't see Max. Anyone else from Tulsa UX here that can talk about what the talk's going to be? So it's going to be Lightning Talk series. It begins at 6 p.m. So if you're interested in speaking, submit your ideas at tulsaux.com/lightning. March 23rd is Django Girls Tulsa. I'll give a special shout out to this one. So if you go to djangogirls.org/Tulsa, this is a free programming workshop for women. It will be at the library. It is Friday night. We will help you install Django onto your machine. And then Saturday, we will coach you through setting up a simple blog website in Django. There's no pressure to get the whole thing done or whatever. It's just there'll be one coach there for every 3 students. So you'll have lots of hands-on time with a Django expert who can help you get through that one. So you can go to djangogirls.org/Tulsa to register either as a student or if you can coach, let me know. There's a link to the sign-up form for coaching. I believe it's on here, but if it's not, come find me and I'll give it to you. So that one is that. Oh, I should also say, I forgot to put it on here because it feels like it's a long way away, but it's not. So 200 OK this year is on May 17th, so put this on your calendar. We do this every year. It is a single day full of talks. There's usually 5 full-length talks and then 5 lightning talks covering all kinds of web development topics from 3D and animation to security and UX and Lambda functions and all kinds of stuff. So everything is fair game. Right now, what we're looking for is speakers. So if you go to 200ok.us and submit talks, that will take you to this handy-dandy site that tells you kind of what we're looking for in the talks. Make your talk title very descriptive because we do a round of voting on the talk titles before we do the full evaluation. You can submit as many proposals as you want. We suggest you submit at least 2. We'll make the determinations 2 weeks after all the proposals are in. The full talks are 50 minutes, including Q&A, and lightning talks are 5 minutes, with a panel Q&A after all of the lightning talks. Probably doesn't apply to people here, but we are paying for airfare and hotels and stuff for speakers who come from out of town. You get a free conference ticket, obviously. And then all the topics here, so 3D, art, audio, distributed programming, hardware and IoT, pretty much anything goes. So that's it. If you have wanted to speak at a conference, the lightning talk route at 200 OK is actually a really cool way to sort of prepare a short, quick one. Vic, I see Vic, right? Vic did a lightning talk. Who else did a lightning talk at last year's? No one else is in here, but so yeah, it was fun, right, Vic? Yeah. Okay. Yep. Okay, so that looks like all the announcements that I have. Is there anything else that I'm forgetting? Anyone? Robin was first.
On Tuesday here, OKWIT is hosting the quarterly programming event. So it's going to be, we have an awesome speaker who is going to share kind of her story and her background from, hey, growing up without internet to now she has a successful career within technology and how she made all that happen. And then the idea being we're going to talk about like, hey, what are those big dreams that seem impossible that you have, and then break it down to like really possible actionable steps that you can take to get there. And so this is going to be on Tuesday, and it's going to be pretty cool. It'll be here, so sign up online.
Okay, so that's tomorrow?
Sorry, next Tuesday.
Next Tuesday. Okay, so for the stream and microphone bit, it was OKWIT having their quarterly presentation here at 36 Degrees North a week from tomorrow, which would be the 26th, so February 26th. And the speaker is going to talk about overcoming major obstacles with an emphasis on a career in tech. Okay, cool. And then Dante?
Tulsa Open Source Hardware is meeting at the UK Makerspace on Wednesday, 6 p.m., though we really get underway more like 6:30. And I am, as the vice president, I am presenting. And I'm going to present a short bit about the microbit, which is sort of the non-retro, wait, what do you call it, of sort of bringing back teaching kids how to program, because you can program it in its own little shiny thing, but also in MicroPython. And yet the device is $17. It has an accelerometer. It comes with a 5x5 LED grid and 2 buttons. So I'm going to try to make this into a shiny dice.
Cool. So it's Tulsa Open Source Hardware, and that is this week, Wednesday, February 20th. Okay, and so the topic here is the MicroPython boards and MicroPython demonstrations and turning a MicroPython board into little blinky dice. Sweet. Cool. That looks like it. No other hands are going up. Okay. So tonight we've got a few breakouts. Each of you are going to come up and give a short, because you have to come up to the microphone, Greg. I see you reluctantly not wanting to come up to the microphone yet. Okay, so Greg, and then is Daniel actually here? I thought he said he couldn't come.
No, he's virtual for Slack.
Oh, okay. And then Tulsa Systems, Learning Go, who's going to talk? Okay, cool. So do it in that order.
Hey everyone, I'm Greg Tatum. My talk is, if I can remember the title, Writing Rust for the Web with Wasm. So Wasm is WebAssembly, which lets you target different languages to the browser. It is sort of new tech and is just coming into the point where it can start being used prime time. And so my talk will be exploring what Wasm is, how you use it, and then drawing pretty things on the screen with it. So yep, that's it.
Hi, I'm Ryan Quinn. I'm with Tulsa Systems. My talk is about getting started with Go, Google's programming language. It talks about getting installed, talks about the tooling, and we do a little bit of code demonstrations.
I am not Daniel Ashcroft. Ashcraft, I'm sorry. He wasn't able to make it, but we'll still get together as Code for Tulsa to kind of talk about a little bit of the criminal justice projects that we're working on, primarily CourtBot and hopefully soon Clear My Record. So if you're interested in criminal justice and or writing civic tech stuff, then come join us.
Okay, so this is the non-committal part of the evening where I ask you to raise your hands of which talks you're interested in, just so I know the relative size of the room that's needed. You don't have to go to this one, but please be honest here because we need the right room size. So the first one was the Rust for Web with Wasm. Okay, and then how about the Learning Go? Okay, and then the Code for Tulsa. There's a lot of Code for Tulsa. So Code for Tulsa is going to take the boardroom, and then Wasm will be out here. And then I think Go, if you need screens, these two rooms, you can actually open the door in those two rooms, so you can get both of those rooms together if you need it. Is that good? Okay, cool. So Wasm is out here. Code for Tulsa is in the boardroom. And then Go is in these two small rooms right here. So grab some more food. I'm going to make the last announcement because we never get to do this, but there's a lot of people that typically just walk next door to Prairie afterwards. So we have to get out of here by 8 o'clock. Please get out of here by 8. But if you want to keep having conversations, Prairie Brew Pub is right next door. So I think that's it. Thanks, everyone.
Okay, hey everyone. We'll go ahead and get started. If you want to move closer to see the screen better and heckle me better, I highly encourage it. Please interrupt me with questions while I'm talking and telling me I'm wrong. It's really fun trying to like figure out like what I don't know on stage. Anyway, so hey everyone, I'm Greg Tatum. I work for Mozilla, so I work on the Firefox profiler, trying to make Firefox faster. So I spend a lot of my time looking at performance data about how to make things faster. And so looking at WebAssembly, one of the stories that people tell a lot is that it will let you write fast code, or code that runs fast. So what I'm going to do with this talk is kind of go through what exactly WebAssembly is, which I'll probably switch to just to saying Wasm from here on out. And what it's for, how it works, and everything that you have questions about. And with that, I'll talk also about using Rust as a language for the web through Wasm. So that's my talk title, Writing Rust for the Web with Wasm, which is just kind of a mouthful. I feel like a cartoon character. So what is WebAssembly? It's essentially running assembly in the browser. So you download binary code from some random person from Russia, and you run it on your computer, and it runs really fast. Or maybe not from Russia, maybe some code from Russia. It's a low-level bytecode. So essentially, in the Firefox source code, all the WebAssembly code to run WebAssembly is inside the JavaScript engine. So it's sort of JavaScript-ish, I guess, but it's not JavaScript at all. It's code you're taking from someone else and running it. So kind of a simplified little diagram here. The traditional path for running like C code or C++ or Rust is, I don't know why that's doing that, but that's fun. I hope it does it the entire talk. That'd be awesome. Okay, the traditional path is taking something like C code, running it through a compiler, and things happen, things get linked, and blah, blah, blah. And ultimately, you get basically assembly or ones and zeros of how that works. So a compiled language, you have a step that happens that takes your code that you write and transform it into the step that the computer can run. But there's so many levels of abstraction depending on what language you're using that this is just kind of a high level to look at it. There's a lot more complexity that goes into it. But the WebAssembly path is if you have a step where you compile down to machine code, you can, if someone develops a way to target WebAssembly, it becomes almost trivial to take whatever language, whatever ecosystem that you are happy and fluent in, and then transform that to be able to run on the front end of the browser. So this is kind of a crazy way to say, hey, I just like writing C#. Well, maybe one day someone has an integrated front end and back end system all written through C#. And for me, what's exciting is being able to take Rust code, which I'll go into later, and write Rust, which has really interesting implications for trying to write intensive code. So, spoiler alert, JavaScript is fast. It might not seem like it kind of gets a bad rap a lot of times, but you can write JavaScript code that gets to be pretty close to native code. The thing is, to do that consistently, you need to know about how JavaScript works on each engine that you want it to be fast on, and then hack around all these issues. So you have to be an expert in the language and how it's implemented and constantly profile to figure out how to do that. It's great if you have the time and energy and interest to do that, and sometimes it's important that there are people who do that, but not everyone wants to do that, and that's not very maintainable. So one of the benefits is you could write clean code in a language that is really good for known performance characteristics and write that fast code without any tricks. There's some excellent articles out there of people fighting it out online about writing fast code in JavaScript versus Wasm, and it's kind of fun. Hit me up afterwards and I'll link them to you. Another one, like I said, is you can take your language to the web, and kind of one of the promises that I love about the modern internet, which is also kind of sometimes can make the internet a little annoying, but the web is a compile target. So whatever kind of application you would have done before, you can target the web and it just works. So what's the status of this new technology? It runs on all evergreen browsers. So if you just want to see the can I use real quick, that's what it looks like. Ooh. So basically Edge, Firefox, Chrome, Safari, mobile Safari, kind of Android browser, all the big ones support it, and on the kind of evergreen side. As far as like ecosystem, many of the nice things have landed, especially around Rust, which I'll get into more later. Not everything is perfect yet. It is still pretty new territory, but I keep on trying it out every like 6 months or so and feeling blocked. And so this is the first time where I've done it. I'm like, wow, this sort of just works now. This is pretty cool. And really what Wasm is doing is it's building a platform that other people can target. So it really is going to rely on the community to build it out. So this is just a list of awesome WebAssembly languages. Some of them are working, some of them are not. But you can just see, I just want to show you there's like a large list of languages. Who knows how mature it is, how much it actually does work, and how much you can write real code with it. But this is something where you could take Perl and make it run in the browser. Yay! Let's all write in Perl now. I joke, but like some people really love Perl. Debugger, just putting the debugger statement in like in JavaScript, that's still in the works. I know they're actively working on it. I'm not sure the exact status. I need to hit up those folks and figure out. But that is actually being actively worked on. So that'll be exciting when you can finally like just put a debugger statement in and then inspect your code like you would as if it was native JavaScript. That's not quite there yet, but it is in the works. Questions? So for my little thing here, this is using the Canvas API, the 2D Canvas API in the browser, but all the logic to how it's generated is all written in Rust. So there's the JavaScript code is about 5 or 6 lines that says, hey, import this Wasm module. That's all the JavaScript that's in there. And so kind of the dependency tree of what that looks like to kind of get a hello world going and getting your development environment set up. First, you need Rust. Maybe that's obvious. If you make sure that is, you can compile that on your computer. And I've only tried this on my Mac. I haven't tried a Windows setup or Linux or anything. So your mileage may vary. Crates needed. Wasm bindgen is the magic that takes your Rust code, which is just kind of assembly code, and then binds that to the web. I'm not sure the exact magical mechanism that goes through to do that. I haven't really looked into the implementation details. But built on top of that are these two really nice libraries, JSSys and WebSys. So this, if you've ever written any Rust, this should look familiar. It is the built-in doc generation through Rust, and it has all kinds of built-in JavaScript things. So you can get a float32 array of JavaScript memory inside your Wasm code that you can then manipulate, which is kind of a weird thing. You can use the JavaScript date object. You can create JavaScript booleans, arrays, and all kinds of things that interact with them. And the real JS objects, you just have a handle on them from the Rust side. Good. Oh. Lost the signal. Oh, okay. There we go. And then, so that's pretty cool, but what's even more exciting, I think, is the WebSys library, which is all of the huge list of things that you can do on the web, like access the DOM. There's going to be the WebGL stuff in there, so you could write WebGL code. You can write 2D canvas. And so I really spent most of my time looking at the WebSys crate to figure out what I wanted to do. And finally, for my personal setup here, I used Webpack to bundle my dependencies and this utility called Watch, because Webpack, at the time I wrote this, which was like a month ago, didn't have the ability to kind of automatically do it. I'm guessing any day now, if it hasn't happened already, that it's going to exist here pretty soon. I'm pretty sure. But that's all live reloading and everything. So just so you know, JSSys was just, and WebSys were finally published just in the fall or winter, just really recently. So this is really new stuff. So these examples I'm going to show now is you might be wondering, okay, I've talked about this thing called WebAssembly. What does it actually look like? Which I find it's helpful just to see, hey, this is just a thing that you're loading, and so let's look at it. There's a text representation of WebAssembly that uses S expressions, which looks very Lispy. And this is kind of the step just above when it gets compiled down. So this is a simple function to add two I32s, and that's what it looks like. And that would be a WAT file, W-A-T, WAT. And so if you want to get the binary representation of that, that's in hex. If you compile that to WebAssembly, that's ultimately the data that you're getting. Or, I mean, literally, just like, here's the ones and zeros for it. It's ones and zeros. This is what you're getting over when you're downloading a Wasm file. But that's not very interesting. What's more interesting is looking at what does that sort of mean. And so there's this Wasm binary magic value, and then the binary version number, and then you start getting into different parts of the actual assembly of defining how things work. And if you know assembly, then you should give a talk on assembly sometime and teach me how it works better than I know. But this is how you get a really well-known performance characteristic, because you're writing very low-level instructions, and the amount of abstraction the browser needs to do to execute those in a safe memory space so that it doesn't break out, doesn't access the files on your computer and everything, is a much easier problem to optimize for. And since it's a compiled language, you can write your high-level language, and then your compiler does a lot of the work to get it fast. So what's interesting is actually just looking at this example. It takes a little while for it to run, because it's running slower than a full release build. So there's a big speed up on doing a debug version versus a release version. So, but that's because my compiler is not putting debug information in there. It's spending more time optimizing my code. So the compile time is longer, but then when I run it, it is significantly faster. And for some reason, my JavaScript code is not highlighting nicely, so sorry. But the web API for the JavaScript is essentially WebAssembly, instantiate, streaming, fetch, add function, Wasm, and then you can call your function from JavaScript, and that's how you get access to it from the bigger side. So that's kind of the abstract, what is this Wasm thing part of the talk. And are there any questions? So moving on. Yeah, let's go into Everyone likes setting up their build configuration, right? That's your favorite part of the project. Yay, exciting idea. Let me set up my build. Let's go through the build. I'm really glad that my text is doing this. I'm trying to decide, if I change the size, is it going to stop doing this? Ah, it did. The problem is I changed my theme right before the talk, so it's the light theme. So all my custom tweaks are now custom breaks on everything. So this is literally all my Webpack config, and when I looked at it afterwards, I was like, why do I need Webpack here? I don't. But I was just using it, and so it's there. Essentially, I'm taking my index file, which is index.js, which is this. I get that nice import syntax. Yay, that's worth Webpack being in there. But it imports actually, no, yeah. So I'm importing my built file and then running it, basically. So Webpack is not really doing a ton right here. But what's interesting is my bash file. I'm sorry I'm just showing you a bash file, but I think it might be helpful. When I run it, it runs cargo, and I'm using the nightly version of Rust because a lot of the features are using and relying on experimental features. So it's great that you're basically exposed to the less stable version of Rust because it is basically pretty new stuff. And the build target is this kind of weird Wasm 32 unknown. So it's an unknown chipset and architecture, but it's Wasm 32. And then I have something that lets me throw on flags for it. So what I do is I actually go through all of my Rust code and then run this. The cargo build is my compiler. So that is generating binary code for me, or generating all my objects to build everything. And then finally, I take this little Wasm blob that's been generated, and I run Wasm bindgen, and this does the magic of binding to web APIs, and has it go out to an out directory for target/JS. So then I just relied on some build scripts to just run watch. Let's see here. Watch. It clears out. It runs the build script anytime my source directory goes, and then Webpack listens to that. So it's not the most optimal way to do it, but it was effective enough to get live reloading. But ultimately, I get these. I'm just loading binary up in my editor, but this is the WebAssembly blob that gets generated. This kind of file over here, ultimately. Okay, so how do you go from a boring build script to drawing something on the screen? So let's start diving into that. And trying to decide who wants to. Okay, raise your hand if you want to know more about Rust. Raise your hand if you want to know more about how WebAssembly works. Raise your hand if you want to know more about how I drew the thing on the screen and what went into it. Okay, it's about even. So Rust, I'm gonna start showing some Rust code. So before I do that, I feel like I should talk about what exactly Rust is. So what is Rust? I stole this from a talk I gave earlier. So let's see how up to date it is. So Rust is basically a language that is Mozilla backed, but it's an independent organization. It's a systems level language, so you can build a browser in it. It's not going to be like a scripting language. And one of its key features is that it's type safe. And so a lot of security bugs come from memory safety issues and things like that. So the type safety is really important, and also no undefined behavior. Again, this is where a lot of security bugs happen. So when you're building a browser, you care a lot about security bugs, because if you let a CSS filter hijack your computer, that's not a good day. Did you know that sometimes CSS filters have hijacked browsers? Theoretically, yeah. I have to talk about the competitor whenever I talk about a security issue. Safe memory access, but all of this stuff, there's all this safety and knowability built into to it. But there's an unsafe kind of pressure valve. I'm doing air quotes here. Where you can actually write stuff that's not type safe. So you can actually get out of those constraints when you have to, because sometimes you have to solve problems that just don't work well for the type system, but you're explicit about it. And if you're reviewing code and you see this unsafe keyword, you're like, okay, I'm rejecting this. You should rewrite it to not use unsafe, or justify why you are. Rust has really nice ergonomics. Everyone who works on it really cares about building a nice language to use. Cargo, the package manager, is beautifully built and fun to use, as much as like I can say that about a package manager. But there's style enforcement, which is amazing, built into the language, so there's no arguing over tabs or spaces or anything. You get 4 spaces, so it's big, like huge space thingy, but whatever. Docs are built into the language. Testing is built into the language. Seasoned systems level engineers who've been figuring out tough C++ bugs for years were the ones who really pushed this language forward. It's backed by a lot of Mozilla research, and I like to say it's backed by people who like nice things. So going from writing Rust, where you are writing some parallel code or something that it could be really risky, but you just know it's going to work because the compiler told you so, and then writing C++ where you're like, I have to go figure out everything that might depend on this value as I'm working on it. So it gives you a lot of nice things. It's also probably a lot harder to write than JavaScript. You're going to be fighting the compiler a lot because the compiler will tell you that you're wrong, and spoiler alert, you're wrong. Like it's telling you you're wrong for a reason. But sometimes the error messages can be cryptic. So let's go back to look at how am I interacting with the page now. So I wrote a whole bunch of small functions that took some of the boilerplate of working with WebSys, which is annoying because everything is kind of optional. You have to, it may exist, it may not. And so I wrapped it all to just basically throw an error if it didn't exist. So here I have a function called document, and it returns a WebSys document. And the way I do that is here up the top. Oh, I guess this prelude probably pulls it all in. Sorry, I'm jumping around. But this is going to return a WebSys window, which I have to, then I'll get the document from it, which may or may not exist, and I run this expect thing. And if it doesn't exist, this will actually throw an error in my browser, which will show up in my console that says, should have a document on window. And so I went through and manually wrote the errors because otherwise it's very cryptic on what the error message is. So I tried to make sure every time I was doing something that could fail, I would have nice error messages with it. Again, like the body element may not exist. Here's getting the window device pixel width, which I wanted as a float 64. And so you can see here's the magical incantation to do that, which I didn't want to do every time I wanted to just use the device pixel width. And so that's just the size of the screen in device pixels. And if you look at this, it says, you might think, oh, that's a lot of code. It's going to run slow. But really what you're telling the type system, here's what I want to do with all this stuff. And the compiler just sort of makes most of that boilerplate go away. And then you have a simple one-liner that ends up being compiled. Okay, so here's a little bit more of a non-trivial example. This gets a 2D rendering context, which involves a few kind of magical incantations in the browser to get that to work. So it's kind of a nice thing to see, okay, let's go through a few different operations and see what happens. This runs my document. Oh, that's my document function that I had earlier. I can actually run, this should look familiar, get element by ID canvas, but it's conforming to Rust style, so it's got underscores there. And again, my expect, so I get nice errors. So maybe what'd be fun is now that we see this line, to see what happens if it fails, because I'm doing a get element by ID. And so if I go to my index.html, the problem is I don't know which one the Webpack will use. I'm guessing this one. And we comment that out. This is what it looks like now whenever I have an error. So I removed that canvas from the page, and I let it be a runtime error. So this says panicked at, and that's my message. A canvas element must be selected. Let's see what happens when we click it. Probably not good things. So here you can see some of the rougher edges, right? I'm not getting my, there's the Wasm code. It's like, okay, I guess that's the text representation of my code. That's not too helpful. So I'm definitely still going to show you the rougher sides of working with newer technology. And this is all stuff that ideally will be abstracted to be nice, but it's not quite there yet. Yep, and so when I put it back, it works again. And you could do a more graceful way of handling that, but that was just an easy way of doing a demo to make sure I get everything working. Now in Rust, a lot of times you don't know if values exist, and you have to do things like unwrapping them to get at the actual object. So you have this, well, it might exist, it might not. And so a lot of this is not as ergonomic as just writing some JavaScript for sure, dealing with it. But that's why I took all these functions and then wrote a single file called dom.rs and collected them all to do that. And this function is ugly. Let's look at it. This starts a request animation frame loop. And if we had another hour for this talk, we could go through how it works. This is not pretty. But this is getting around some issues with Rust is not issues, but getting around some ways that Rust tracks that you are not leaking stuff. So this was me intentionally trying to leak an object. Questions? Thoughts? So, what is this? Let's start talking about the visualization and how I'm drawing it. So the rules here are basically draw a line. So I need to be able to represent a line, which is 2 points in space. And I need it to be able to grow and branch over time. And I've got 4 trees here, and these are true trees from a data structure's perspective. So I've got 4 trees that all grow, and then I have to test for intersections for every line. So the most intensive part of this application is being able to test for an intersection of when 2 points are going through. So if you have just a whole bunch of lines on the screen, it is going to be very slow if you just do a for loop and start with the first one and start checking intersections for each one. So when I'm writing an application and I want it to be fast, the first thing I do is make it really, really slow but simple to write. So the first thing I'll do is write a check intersections function. which hopefully I can just find in my code base. I'm not sure if this will be interesting, but we'll give it a quick 10 seconds. So this takes a list of intersections and finds the nearest to the node. So this code will just like take the distance squared of something and find it. So when I'm like writing these operations, a lot of times I'll just write little simple utility functions to find it and write it so that's slow, and then branch out and add complexity there. So the hardest part then is like figuring out how do you speed it up. And for me, I found this module called Archery, and this does if you've ever done game programming, this is something that is a data structure you can put things into and then look them up quicker. And so instead of just going through every list of possible intersections across the entire set of lines, I created an archery, and then you can put one in there, and it organizes in a way that it can quickly find the intersecting points. So what I do is I take all of my lines and see which ones are all contained within the same kind of bounding box and return that smaller set, and then check for intersections over it. So a bounding box would have would be intersecting if it was like this, because if you just drew a box over it, the two lines would be in the same space, but they wouldn't actually be intersecting. I would need to do a real intersection check to see if those 2 points are intersecting. But this is where I have a speed problem, so I can then use a crate from the internet and install it and then use their data structure. So should I profile this? That seems like it'd be fun. Hold on. Oh, okay, that's the wrong one. Okay. Sorry, I was just making sure I wasn't on the development version of the profiler. So I can use basically all web technology. This is still the web stack, and no one here probably knows this tool because I write it internally for Mozilla. So let's go ahead and show the screenshots too. So here you can see with the screenshots, this is growing the code, growing the trees as it goes through. And you can see the performance characteristics. So the height of this graph is how long it's taking. And the yellow is JavaScript. In this case, it's actually Wasm, and how much time it's taking. So you can see as I add more things that it takes longer to draw each frame. And it gets longer and longer and longer. And again, it's actually fast enough on the full version of it, on the release version of it. So I should really be profiling on the release build, but let's just pretend I'm not. I mean, let's just pretend I am and look at the debug build because I have it open right now. Okay, so this is a flaming graph. So this is different than Chrome's performance tools because this one is a summary over all time. While the Chrome one is basically as you go through time, what does the shape of the stack look like? This one is aggregate everything over the entire time and what percentage of time was a function on the stack at the time. And this one gives kind of a pretty graph. You can see my tree node grow function recursively descends into the function. We spend time there. And here is the canvas drawing. So this blue code here is I'm spending 3.72% of my time. Actually, let's look at 3.7 plus 1.7. So like 5% of my time is actually using the Canvas API to do the drawing, while the rest of it, like this growing function, is taking 70% of the time. So That said, I haven't looked at it in Chrome to see what that looks like. Let's do it. So yeah, you can see it says it's got the tree node grow. So it's still got all the same information. So across browsers, this works. It's a technology that is leveraging a lot of the stuff that's already on the web. So your existing tooling, if you're a front-end dev, you can use that and feel comfortable with it. And there's been enough work on getting all this implemented that most of it should work, except for stuff like the debugger statement. Questions? Is there anything else you would like me to show while I'm up here on the stage and you have my attention? Or I have your attention? I have you as a captive audience.
So I came in late. Does this have superior security features to it than JavaScript?
It would be about the same, I think. I mean, so the question is if it has the same security as has different security than like JavaScript. So it's interesting looking at a scripting language versus a compiled language, because a scripting language, you write higher level code and then some interpreter goes and runs it. So you don't have the same class of issues that we would have on a compiled program. So my head is kind of hurting thinking of like what the difference is on the security implications, because if the browser is doing its job and properly sandboxing the code, then you're not going to break out of the web page. You're like in that web page. So I don't see. I guess okay. Let's take this thought experiment now. We have a video game we've built in C++, and we've compiled it for Wasm, and it's hooked up to online play, and then someone could find a memory overflow, pointer overflow exploit, and they load up your web page, and then through the web page run this exploit on your application. Now they own it and can rewrite parts of the game to let them cheat in the game client. So that's like an example of something you could do in there. But that same Russian executable you got from some suspicious website, if you're just loading that into the browser, would have to get through the browser's defenses as well. So you're not as concerned about it exploiting things yet. I haven't really seen any big write-ups about the security implications of. I mean, essentially, you're running into the same problems of just running arbitrary code online. That's the same kind of threat model that's there. So there's like your browser can be exploited, but yeah. Other questions?
More of a question for like Rust, like legacy systems aside, because no one wants to go back and replace all of that code. Is it looking like Rust is probably a likely replacement for C++ or even C?
So the question is Rust looking like a replacement for something like C or C++? And the short answer is Rust is designed to be like the ideal language that a C++ developer who has battle scars would be just thrilled to write. I'm going to make up statistics. 70% of, there was a recent study from Microsoft patches, and 70% of the errors, security issues were memory errors and things that Rust is specifically designed not to allow. And my personal experience is I am a beginner intermediate level Rust, and I'm intermediate C++. And so I'm doing a lot of my learning both of them at the same time. And so when I go and write a parallel processed thing in Rust and C++, I'm terrified of my C++ code. While with my Rust code, I'm reasonably satisfied with it and happy with it because of the type level guarantees that happen. So the compiler you can really rely on it. I mean, a compiler is not going to catch every class of issue you'll ever run into. You're going to still have bugs. What it does do is it just makes a whole class of issues go away. So for C and C++, Rust is a really exciting target. There's just a huge cost to rewriting components from one language to another. Mozilla has a whole research arm of the organization who has been writing a new browser from scratch in Rust. If you go, you can open it and load it and point it at a web page, and you're not going to have a great experience because it's kind of it's more about the architecture of what's going in there. But 2 years ago, there's a big effort to take all of that and start landing that Rust code in the browser. The thing is, you have to take decades of hacks and band-aids and things that made the old C++ code really fast and compatible with the web, and then start working on getting that same level of compatibility with a brand new component. And so the architecture might be a lot better and a lot nicer, but you still have to do all the tweaking and tuning that makes it shine. Which that's basically done work now for a lot of the components we've landed, and it makes the code a lot more maintainable and easy to use. But you can run C++ code and Rust code at the same time. Just much like you can run with Wasm, you can call a JavaScript function. In Rust, you can run a C++ function or a C function or an Objective-C. You need essentially a foreign function interface to call out to those. So a lot of the ecosystem is built on the same type of thing. Are there other questions?
Scott back here missed the first part. What was your purpose or goal? I mean, obviously it makes a beautiful picture, but what were you playing around with?
Oh, so yeah, this was mainly, so the question was, what was I playing around with? What was the goal here? This one is, I have a lot of different visualizations I've done over time, and I find usually exploring abstract computer concepts is very dull and boring to other people. So I like to make something pretty so that whenever I can explore something that is maybe more on the technical side, there's an artifact I can say, hey, look, it's pretty. And then someone's like, oh, yeah, it is great. And I can have different levels of interaction because some rooms of people might be interested in just seeing a cool trick on the computer, and some might be interested in knowing the difference between Rust and C++ and like migrating legacy systems and things like that. So it makes it so I can take something I'm passionate and interested with and then be able to apply it to different audiences. So you what? Yeah. Yeah, it's playing and it's also learning. So
I've been playing and dabbling in Rust for a while now. Really like it. I've had a lot of fun with it. I'm curious how many other people are doing the same.
So the question is, how many other people are playing around with Rust and Wasm and everything else? So I think a lot of company cultures tend to focus around certain languages, especially if they're backed by a company. So Rust was really the brainchild of employees at Mozilla, but Mozilla's done a lot to both support it and push it out into the greater community so that Mozilla's not the primary owner. And Mozilla does this a lot with technologies, trying not to be just the sole organization that's involved. So I think a lot of people look at different competitors being like Go for different web services, which a Google employee is going to be much more ready to just grab Go, and there might be an existing ecosystem there. And they have tons of C++ code that's available. And like wonderful standards that they've written to ensure they write quality C++. So there's a lot of organizational knowledge around it. So building up an entire new ecosystem around it is hugely challenging. But the thing is that it's pretty obvious using it what the compelling case is. So a lot of systems engineers are spending a lot of their free time learning it. There's a huge organizational cost to start using it. If you're writing an evergreen project, brand new code, Rust is a fun, great fit, but it takes a long time for something to mature as much as a language like C++ has been around a very long time, and there's a lot of the code of the world is run on it. But there are a lot of security issues with that and reliability. If you find the memes online of if I were to build something that I'm shooting a human being up in a rocket, my cost for failure is going to be huge. So I want to be as the most dependable I can. So I would definitely choose Rust for something like that compared to something like C++. So it just depends on where that sliding scale is. For Mozilla, it has been. Sorry, my screen went dark. For Mozilla, it's how do you take 20 years of code and migrate that to a new language? So the decision from Mozilla was to kind of target different components and essentially build an entire browser over here and then figure out and play around with the architecture, take that component, and then put it into the rest of the browser, which is a pretty risky move. It turns out like it worked. But that was kind of a risky operation to do and took a lot of engineering time to do it. And the community has grown like crazy. So it is definitely showing all the signs of having more and more people using it. And the community is one that is actually welcoming and inclusive, which I find very valuable. Sometimes C++ can be very, like if you're gonna be writing C++, there's a lot of gnarly bits to it, and you have to have some deep platform knowledge. And I think people take pride in the fact after they've been writing that kind of code for 5 or 10 years, it's like easy. It's like, oh, I write C++. Like I know what I'm doing. But the thing is, you don't know what your code is doing. Your code is full of holes, and everyone's code is. So how do you manage those problems? So I think I see more and more people, especially like at the systems level. I think for like front end code, it's fun, and I enjoy playing around with it. But I think the big thing with Wasm, with WebAssembly, is the fact that people will take their existing ecosystems, which are already rich, already developed, and start putting them into the browser. One more question? Anyone else?
Where's the name Rust come from?
No idea, but there's lots of crabs involved in all the the branding and rustations, I think is what they call themselves. But yeah, I don't know. All right, well, thank you so much. Feel free to grab me if you have any questions.